Hello, my name is Hayden, and I'm going to show you how to do a triple integral to find the volume of this cube here. Now you may be thinking, I took high school math. I know how to find the area of a cube. Well, that's not all I'm trying to do. What I'm going to do is show you my collapsing method. I didn't come up with it myself, but it really helps you visualize what's going on and what to do next when you're doing these triple integrals. But before we get there, what are we going to integrate by? We got dx, dy, and dz. Well, since our bounds are only constants, we don't really care what order we integrate in. Now, if it was a slope, like kind of a wedge instead of a cube, imagine this cut in half here, then we'd have to have a bounds of y equals x or something similar. And then our integration bounds, or order of integration, would matter very much. But anyways, let's get started here. We've got the integral f of x. Now it doesn't matter what our bounds are, so dx, dy, dz. Now, we're finding that volume of something, and usually that means that our integrand here is just going to be simply 1. So let me backtrack on that real quick here. Oh no. There we go. Sorry. Okay. Now, the x bound goes from 0 to 3, and that's my first one here I'm going to do. So simply write 0 to 3 here. For y, same thing. You're going from 0 to 5. And z also goes, well, z goes from 0 to 6. Alright, now just integrate. When you integrate 1 with respect to whatever variable you're integrating with, it's just going to give you that variable back. So for this 1 here, we're just going to have an x. But don't forget to write your other integrands so you stay nice and neat and you know exactly where you are in the problem. We drop out this one because we just did it. We just have an x there now. X runs from 0 to 3. Don't forget these. Alright, well, you take the upper minus the lower here to fully evaluate the integral. Well, that would be 3 minus 0, so we could just write 3 and carry on with our day. Excuse my sloppy handwriting. This is on a mouse. Anyways, it's the same thing. This is just a constant, so we add a y right to that. And then we evaluate that from 0 to 3. Well, oh, excuse me, that should be a 5. Shoot, my bad. Same goes though. We're just going to evaluate 3y from 0 to 5. I think that's worth writing. Once again, integrating 3, it's a constant, so you just add the variable you're integrating with respect to this dy right there. Well, once again, 0 drops out that, so we're just left with 3 times 5, 15. Oh, I forgot my dz. Give myself some more room here. Excuse me. Alright. 3 times 5 is 15. Now we just have the integral from 0 to 6 of 15 of dz. Same thing. Add that constant. 0. Well, no, that's gone now, sorry. 15z from 0 to 6. Once again, upper minus lower, we have a 90 minus 0. So that comes out to 90, which is the area of this cube here. Now, what I want to expand on here is the collapsing method that helps you visualize what's going on while you're doing this. When you integrate this right here, and you get left with this right here, you can now look at this cube on just the YZ plane. Come back up here, well, that's this face back here. And what do those bounds go from? Well, they go from 0 to 5 and 0 to 6. And the same goes for the next integrand. We collapse once more and we're left with just a line on the z-axis that runs from 0 to 6. If you get that, then you understood the main part of this tutorial here. This collapsing method is really going to help you visualize where to set your bounds and how to set them. Because if you have a wedge, I guess, like this, it's not going to be anywhere near as simple, because when you try to set your bounds here, you're going from 0 to what is this? This is a plane. You need the equation of that plane. Let's just say it's y equals x. Now, if we had that, we would begin with this dy first, because it's y equals x. We don't have to do anything crazy, but we could swap it. We could have dx first, because it'd just be x. Anyways, we'd go from 0 to x instead. And then we'd do the rest of our stuff, 0 to 5, 0 to 6. Of 1, because we're still evaluating a volume of a 3D object. Now this is going to give you a little bit more grief, but nothing crazy, because when you integrate this 1 here, well, you get an x, and what are you gonna, or you get a y, excuse me, and then you just put an x into that y, and then you do the same stuff that we were doing up here. I really hope this helped you. It helped me visualize what's going on. I know the math here wasn't anything crazy, but it's the conceptual idea of collapsing that I really want you to understand. Thank you for your time.